Alright, we're going to do a video lesson today since I'm unable to be in class, and our video lesson is going to be on adding and subtracting rational expressions. And we need to remember, we did our simplifying, multiplying, and dividing rationals before break, and we said rational expressions were just variable expressions built into a fraction. And before break, on that last day on Friday, we actually went through and did a worksheet on adding and subtracting fractions where I asked you to do that without a calculator. And we reviewed why you have to have a common denominator when you add and subtract. Well, if you need a common denominator to add and subtract fractions, then you also need a common denominator for adding and subtracting rationals. So we're going to walk through 3 or 4 examples here today where we're going to look at how to find a common denominator when you have a variable fraction and how to go ahead and combine those like terms when adding and subtracting. So our first example, to begin with, we're going to look at our fraction up here in the upper right hand corner, 2/5 plus 1/3. And we're going to use a guide problem here to do this. And we're just going to look at a basic fraction. If you have fifths and thirds, we need a common denominator. Now, we said this always works on Friday, that you can multiply by the opposite denominator on both sides, and that will give you a common denominator, where both our answers become in terms of 15ths. And then when I add those together, 6/15 plus 5/15 is 11/15. Well, we're going to use that as a guide problem to look at 3 over 2x plus 5x over 5. We can always use that method for finding a common denominator. I can always multiply by the opposite denominator in order to make the denominators be the same. So I'm going to multiply this fraction by 5 over 5, and I'm going to multiply this fraction by 2x over 2x, because that's my common denominator. I'm sorry, that's my denominator of my opposite fraction. So when I multiply those together, I get 15 over 10x plus 5x times 2x is 10x squared over 10x. And so now I have both fractions over 10x. That means I can add them together, and when I add fractions, just like I did up here, the denominator was 15ths and it stayed 15ths in my answer. In the same way here, our answer is going to stay 10x in the denominator. All I do is I add the numerators. So my answer is going to be 10x squared plus 15 over 10x, because those are not like terms, so I can't add them together. I simply write it out as 10x squared plus 15 over 10x. So in this case, all we've done is taken 2 fractions and write them as a single fraction with an expression on top. Now, as we look at multiplying by the opposite denominator, that's a nice trick. It always works. It will always get you to the correct answer. However, it's not always the easiest method. If you look at example 2 here, and I have my guide problem of 4/5 plus 7/15. If I would go ahead and find my common denominator by multiplying by the opposite on each side, I end up with an ugly problem like 60/75 plus 35/75, which gives me 95/75. And then I'd have to simplify that answer. That seems like a lot of work, and that ends up being way, way, way more work than is necessary, because those of us with good number sense would never multiply by the opposite denominator in this problem. Because when you look at 4/5 plus 7/15, hopefully you're recognizing that I can turn 5 into 15. I don't need to make them into 75ths, because I can make 4/5 into 12/15. So I don't even have to change my second fraction, and I get a much nicer number of 19/15. Now, if you had gone with our first method and gotten 95/75, you would end up with the same answer. That will reduce down to 19/15. You just did about 3 times the amount of necessary work. And that same thing will be true here in our example with rationals. When I look at my denominators in this problem, I have 3x minus 6 and 3. I could multiply the left side by 3 over 3 and multiply the right side by 3x minus 6 over 3x minus 6. However, that would end up creating a really ugly situation, and I want to do these problems as simply as possible if I can. So in order to do that, I'm going to take my denominator on the left side here, and I'm going to factor out a 3. If I write that in factored form as 3 times x minus 2, we look at our two denominators now, and I can say, what do I need to multiply the one on the right by to make them the same? Well, to make them the same, I need to multiply by x minus 2. And whatever I do to the bottom, I need to do to the top. So by factoring the bottom, it allowed me to find my common denominator much more easily. My common denominator is 3 times x minus 2. So therefore, I have this problem now. On the right side, when I multiply 2x times x minus 2, I have to make sure I'm distributing 2x squared minus 4x over 3 times x minus 2. I now have a common denominator. Both fractions have 3 times x minus 2 on the bottom. So I can add those together. I have a 2x squared. 2x and negative 4x make negative 2x. And the minus 5 is still there. So there's my answer. And I can always leave my denominators in factored form. So we're going to go ahead and move on to example 3. Make sure if at any point here we're going too quickly, go ahead and pause the video so that you can go back and look at whatever you need to look at. Now, here's an example where you have denominators that are completely independent. 2x plus 1, x plus 6. Neither one of those denominators can be simplified at all, factored at all. So therefore, to do this, I'm going to go ahead and multiply by the opposite denominator. If I can't do any factoring, then I'm going to go ahead and go to my old shortcut of multiplying by the opposite denominator. It's kind of my old standby. It will always work. So now when I multiply this out, on top I distribute, I get 3x squared plus 18x over x plus 6 times 2x plus 1. On the right side, I multiply 5 by both of those, and I get 10x plus 5 over x plus 6 times 2x plus 1. Now my denominators are the same, and I can go ahead and combine my like terms on top. I just need to be careful here. When I'm subtracting rationals, I kind of treat them like they're in parentheses, and I have to distribute that minus to the entire second part of the problem. So my answer is 3x squared, and I have 18x minus 10x, which is 8x, so I plus 8x, and then I have to minus the 5 because that subtraction applies to the entire second fraction. And my denominator is x plus 6 times 2x plus 1. You can always leave your denominators in factored form. So sometimes, in order to find a common denominator, we are going to multiply by the opposite denominator. Other times, we're going to be able to look at a problem like this and say, oh, I can come up with a common denominator in an easier way. So you're going to have to be able to use some recognition there. All right, our final example here is going to be our ugliest problem in appearance. The way it starts, it looks ugly, but it ends up being actually a shorter problem. Because if I want to get a common denominator here, I have an x plus 6 on the left and then a trinomial on the right. However, if I would factor that trinomial on the right, That's actually x minus 8 times x plus 6. So you should hopefully recognize that both denominators have an x plus 6 in them. So in order to make the denominators look exactly the same, I need to multiply this one by x minus 8 because it already has x plus 6 in them. And now, if you look on the left, I have x minus 8 times x plus 6, which is the same as the denominator in the second one. So I'm not going to need to change the second one at all. So on top, I'm going to multiply that out. We don't FOIL out the bottoms. We can leave those in factored form. But in order to simplify the top, I do have to multiply that out. And so I do x times 4x is 4x squared minus 3x minus 32x plus 24. And now I'm going to save a step here and go ahead and combine those like terms, making it 4x squared minus 35x plus 24 over x minus 8 times x plus 6. And I still have that second fraction. I haven't done anything to that, and I don't need to. It's already in my common denominator, so there's no need to put that together. My final step then is to combine my like terms. My 4x squared has nothing to go with. Negative 35x minus 2x is negative 37x. And 24 minus 7 is positive 17. And so I just need to make sure I'm putting these together, treating that minus like it's distributing through a parenthesis. And I get my final answer of 4x squared minus 37x plus 17 over x minus 8 times x plus 6. That's our most complex example, but what I want you to see is you always want to factor the denominators first to see if there's an easy thing you can multiply by to make the denominators the same. All right, good luck, and you're going to have a worksheet that is on this adding and subtracting, and also a review worksheet on dividing and multiplying, dividing, and simplifying.